Welcome to Lab 4, the magnetic field of a bar magnet. The purpose of this lab was to measure the magnetic field of a bar magnet computationally in GlowScript and experimentally with Phyphox, which is a magnometer app. Some principles that we used are magnetic field. This formula here was given to us in the write-up for the lab, and the Biot-Savart law. So the procedure was using the magnometer app. We first had to compensate for Earth's magnetic field by aligning the phone with the X component so that the X component reads as close to zero as possible. We also had to find the location of the magnometer chip in the phone by aligning the east-west and north-south axis of the phone until those respective X and Y values reached minimum or maximum values. Then we measured the magnetic field at different horizontal distances away from the magnet. Then we measured our off-axis fields, first finding a distance d-perp where the net magnetic field was equal to 100 microtesla. And with the positioning shown in the diagram, we measured the x, y, and z components of the net field at a distance d from the magnet, corrected the b to account for Earth's magnetic field, and then repeated the procedure 3 times to get a mean value. Some approximations and assumptions we made are that the bar magnet acts as a dipole and there's no contribution from Earth's magnetic field because we went through that step of aligning it with magnetic north. So you can see here the recorded data is all written in these yellow boxes. The computer calculated the other results, but really what we're working with here is this formula here generated by the computer, and we're going to use this formula and especially the B value to calculate the magnetic dipole force. So you can see we just used the magnetic field formula on axis and isolated for B because B is the component that has the mu in it. And then solving, we discovered that the mu was 2.149. Now for the code, we went through the same process, just plugging in that mu that we had found just computationally on paper. And then we also calculated for the magnetic force on the magnet. And then all of this code basically is just calculating that same magnetic field at different areas around the magnet. So we did 2 on axis and 4 off axis, which you're going to see later on in the image generated by the code. And then we also did one that was a 45-degree angle off of the axis right here. You could see here that the ones that are on axis have equal magnitude in opposite direction to the movement of the magnet, and then, the dipole moment of the magnet. The ones that are like perpendicular have the same direction but half the magnitude, and there's also, you can't really see it well in this photo, but in theory there's also one in the x direction coming out of the page that has that smaller magnitude and going in the x direction into the page. And then this little tiny purple one in the corner here is the 45-degree angle away from the axis, and you can see that it's much smaller. So what we observed is just the distance dependence of the magnetic field related to how far away from the magnet we were. So we found that when the magnometer is very far away from the magnet, it measures a smaller magnetic field, and predictably, as we get closer to the magnet, the X component of the magnetic field increases. So these two are correct. You can see that the other two just kind of don't make sense based on the data that we have. If we hadn't compensated for magnetic north and I had laid out the meter stick at some intermediate angle, we would have been ignoring the impact of Earth's magnetic field altogether, leading to an incorrect reading by the magnometer, because Earth has a very strong magnetic field, as we found. Just moving the phone around, you can find that, and to not calculate for that would be incorrect. And then if we were to stick 2 identical magnets together end to end, run the experiment again, you can see here in this diagram, I think it shows it pretty well, but the magnets will run in the same direction, with the north and south ends attracting to each other. So it'll just create a stronger overall magnetic field. and the measurements for magnetic field will become much larger. Thank you for watching.